I finally got a microphone. And to celebrate, we're going to build a very simple system that uses Effect AI to generate vector embeddings for chunks of the novel Dracula. We'll initialize a Postgres database and store these Effect AI generated embeddings in that Postgres database. This means that we'll be using the PGVector extension, and we're also going to use Drizzle. Specifically, we're going to use the Effect Drizzle integration. Once the Dracula chunks are in our database, we'll create another effect program that takes some text input and performs a similarity search to print out the most similar passages from the novel. So yeah, the first thing we need is a Docker compose so that we can spin up a Postgres database. In my package.json, I have a few relevant scripts. The first one is DC up. This just runs Docker compose up. The second is Docker compose down-v. This ensures that it will not only stop the container, but remove it. And finally, I have this DC re script, re for restore, wherein I remove the container and then start a new one. So this makes it really easy to iterate with a fresh database. Bun DC re, and it immediately kicks off the database. Next, I define a single table inside of schema/messages. We're using the Drizzle ORMPG core export. I want to keep this example really simple, so we only have 3 columns. The first is a UUID, which serves as the primary key. You can see we're making use of this extension, which we'll get into momentarily. We have a non-null text as the body, and a column for a vector embedding of the body as well. So this table is going to store chunks of the novel Dracula. Each chunk will have an ID, the actual chunk text, and a vector embedding of that chunk text, over which we can do similarity search. In the drizzle.config.ts, config.redacted gives us an effect that resolves to a redacted wrapping the database URL environment variable. So we're going to immediately execute that effect in order to get back a redacted. Then inside of DB credentials, we supply the actual string value by using redacted.value. Now, this isn't strictly necessary here since we're not using the redacted value elsewhere. But based on what I've seen, it's good practice to wrap any sensitive values in a redacted and only unwrap them exactly where you need them. As you can see, we also give a glob for the tables. So anything is going to be inside of this schema directory. Now let's take a look at this ensure pgext script. All that this script is going to do is register these 2 extensions, which we're going to make use of. So the very first line is a simple console log. Second, we grab this PG client, which will allow us to run SQL queries. And then we run a SQL query wherein we enable these 2 extensions. This requires that we pass in the PG client live. If we follow this reference, PG client live is made from pgclient.layerconfig. This comes from the Effect SQL PG package. We give it the redacted database URL, and that's all we need to get a layer for the PG client. Let's open a new terminal and execute this script. Let's run bunx drizzle kit generate. And this will produce our first migrations file. To apply this file, we can run bunx drizzle kit migrate. And now if we open up SQL tools and take a look at this table, and if we look at public and tables, we'll see that there's this table for book chunks. I'll hide the terminal, and right now there's no data inside of this table. So let's write an effect that will populate this with the actual novel Dracula. We'll do a search for Project Gutenberg. And now we should be able to search for Dracula. Here's the novel. And we can access a plain text version of it and save this into our workspace. Although I've already saved it, it's right here under dracula.txt at the root. Here is an ingest script. It's very simple. It has this vectorize function that uses effect.fn. This effect factory takes in the body of the chunk. It accesses an AI embedding model. It triggers the embed. We get a Drizzle instance, which lets us then interact with our database, and we insert into the book chunks table the embedding and the body. So we're going to want to load in the Dracula text, chunk it, and then call vectorize for each of those chunks. The first step is we'll bring in a file system from Effect Platform. We read the Dracula text file into a string, and then we take this string and we pass it into chunk text. We also represent it as an effect. 3 parameters. The first is the text that needs to be chunked. The second is the size of the chunks. And the third value is the amount of overlap between chunks. So the edges of each chunk may share some text in common with their adjacent chunks. In the case that the chunk size is less than or equal to the overlap, then that's an error. So we'll return yield star effect.fail. And the error is going to be this custom chunk size less than overlap error, which we define up here. Using these 2 values, we'll calculate the step, so the number of characters by which to increment in every iteration. We create the result list, which we're going to populate with chunks, and we begin iterating. We calculate the end of the given chunk, and then push a slice derived from the start and the end. So that should do it for our chunk text utility. We're going to use this in order to get our chunks. Then we iterate over all of the chunks, yield a console log just so that we have some visibility into the progress, and then we utilize our vectorize function on the given chunk. In order to run this, we're providing a few dependencies. The first is this live layer, which is constructed from a few different layers. One of them is our Drizzle live. Drizzle live is going to make use of that same PG client live layer that we went over before. The second dependency is our embedding model live. We're using the text embedding ADA 002 model. And then we're going to provide merge with our OpenAI client, which we're passing our redacted OpenAI API key. The final dependency that we specify is the HTTP client. Once we have this layer, we're providing it, and I actually think we can clean this up a little bit. Let's get rid of this and say effect.provide. And now let's run this. Bun ingest. And now we see that it's going through all of the chunks in Dracula and uploading them to our database along with their vector representations. And now that it's finished vectorizing, let's open up SQL tools. We'll take another look at this table, and it's filled with all of the vectorized chunks. Nice. We'll get out of here. And now let's take a look at this search.ts file. This is where we're going to take in some text. We're going to vectorize that text, and then we're going to perform a similarity search using PGVector. The first thing we do is get a terminal instance using the terminal tag from Effect Platform. We tell the user to input some search terms. We get the line of text from standard in. Next, we're going to bring in the embedding model using the AI embedding model tag. We embed the line that the user provided us through standard in. We use the PG Drizzle tag to get the Drizzle reference to our database. We'll use this momentarily. First, we create this portion of the query that we want to construct, wherein we describe the cosine distance between the embedding column of the book chunks table and the embedding that we've generated using Effect AI. And finally, we run our Drizzle query. We select the similarity, and this way we're able to later on order by that similarity. We're going to limit it to 5 rows. This is all strongly typed thanks to Drizzle. And down here, we're going to iterate over all of those chunks and just print out the body. So see what were the most similar items and print them out. Last but not least, we provide our live layer, and let's refactor this once more. Let's run our search script, and we'll do a search for delicious foreign cuisine. Let's scroll to the top of this and see what it gave us. And let's see if we can gauge if there is any similarity. We see orange trees. We see during the time I was eating. We see you must need to eat and rest. We see was my supper, and I had finished my supper, and rubber steak, bits of bacon, onion, and beef seasoned with red pepper and strung on sticks and roasted over the fire. And that's all for today. Thank you for watching.